So HRV, the first step in the Terra Research pipeline is descriptive, and then we follow that with looking for relationships, and then potentially looking at predictive modeling as a third step. But we've got these enormous data sets, as we said in the last one. We're looking at over 1,000 users and nearly 100 days, so that gives us nearly 100,000 individual pairs of data if you're looking at a correlational pair between HRV and sleep, for example. And the first thing we do is we look to describe the data of what it actually looks like, because quite often it's hard for someone else to go into the details of looking at that enormous amount of data over such a large period of time with so many points. And so we've actually found some quite interesting things by just descriptively looking at the data. Cameron?
Yeah, of course. I think we should probably talk now about what our original idea was, as in with the distribution of HRV, we kind of sat down outside, we sat in the sun, we had a bit of lunch, and we said probably HRV, the distribution of it, let's say a user's HRV, let's say the average for each day over the course of a month, probably it's going to be distributed with some sort of skew. And again, we kind of was, is it a right skew, is it a left skew? It's kind of remembering statistics from school. And we said probably there's going to be some sort of skew, the idea being the way at least we intuitively understood it to work is there'll be these big drops, then it'll kind of slowly rebuild back up again.
And yeah, to give people, why do the big drops happen in your experience?
Generally, it's you go for a really long run, you have a really late night. It's
too many drinks.
Yeah, it's something to that effect.
Yeah. And the increases to get back tend to be in smaller steps.
Yes,
you would have thought. And so that would, if you think of a distribution, you can see it in the chart now. That would skew the distribution to see proportionally much more smaller increases and much fewer large negative decreases. And that is kind of what we found. And the next step then was what you're really interested in HRV is not the absolute numbers. So the fact that today yours is 50 and tomorrow it's 60 and mine's 20 and 25 is actually the changes or the long-term trends. Yeah. And so we thought, actually, let's look at day-to-day changes that we defined as delta HRV. So HRV today minus HRV yesterday. And then try to standardise that again, because obviously someone having a change from 20 to 30 is probably much more significant than someone having a change from 110 to 120. Yeah. So we standardised that using Z-scores and plotted the Z-scores descriptively to show the distribution of Z-scores over time, which actually did turn out to be completely normal, which was a bit of a surprise. Or near enough normal. It looks normal.
I think you just kind of squinted and it's like, wow, we expected some sort of skew here. So we expected that there would be more significant, I mean in a statistical sense, decreases than there would be increases. And it turns out that they're actually kind of the same. And whether this is because of some post-processing occurring on the provider side, I think that's a super interesting question that we're now left with.
And we should talk about this distributed across the day of the week, because this does absolutely, it's lovely to find a statistical pattern that you could have guessed beforehand. And insert cliche there, but we saw a very clear trend that the big drops on the whole happen on Thursday and Friday night. So they turn up in the HRV on Friday and Saturday mornings, and then you tend to see the biggest recoveries happening over the weekends, actually, so Saturday and Sunday nights. And for the people's best HRV, when you look at the absolute numbers again, happens on a Monday morning. So if you want to do something hard and productive, it says your system is probably in the best place to do that on a Monday morning.